So section 3.2, example 15, integrating tan k secant j when j is even. All right, so I know that like tangent or secant is secant squared x is tangent x plus 1. So we could easily switch between the two. But what do we choose as our u substitution so that when we derive it, it ends up being part of our function here? So taking a look at this, if we do secant, so secant x, that ends up being, or the derivative with respect to x, that ends up being secant tangent. That's our x's in there. So secant x tangent x. But then that would mean that we have like odd numbers over here, and I'm kind of not crazy about that. But what if we tried with tangent? Let u equal tangent x. Du ends up being secant squared x dx. So I think this is going to be a much more easier thing to use for our u substitution. So let's set it up so that we have that. So the integral of tangent, that's not going to change much. And let's get secant squared x out here, dx. This is going to end up being our du. And we're left with secant squared x. That's our leftover. So now let's change this to be in terms of tangent. So we have tangent 6x times tangent squared x plus 1. And then we have that secant squared x dx. And now that we have that, we could do our u substitution. So let u equal tangent squared x, not squared, just tangent x. Du is going to be secant squared x dx. So now everywhere we see a tangent, we're going to let that equal u. And where we see secant squared x dx, it's going to be replaced with du. So u to the power 6, u squared plus 1 du. Clean it up again. U to the power 8 plus u to the power 6 du. Now we could integrate 1 over 9 u to the power 9 plus 1 over 7 u to the power 7 plus c. We weren't in terms of u, so let's substitute our u back in here. Tan x. I don't like the way I wrote that. 1 over 9 tan to the power 9x. There we go, much better. Plus 1 over 7 tan to the power 7x and plus c. And there we go. That is it. If you have any questions, please feel free to ask. Otherwise, bye.